Hello everyone. Today in this video we'll discuss topic-wise important questions from chapter number 2 polynomials. So let's start with important formulas. First, how we can find sum of zeros and product of zeros for a given quadratic polynomial. So sum of zeros is minus b by a and product of zeros is c by a. Second, how we can find quadratic polynomial when zeros are given to you or directly the sum of zeros or the product of zeros are given to you. Third, how we can find values of expression involving alpha and beta, where alpha and beta are zeros of quadratic polynomial. So now let's move to 7 important topics that are frequently asked in board examination. Let's see all the topics one by one. First, types of polynomial. Under this topic, I have written two questions for you. In first question, you have to find the value of m if the polynomial x m square minus 1 plus 3x m by 2 plus 2 is a cubic polynomial. So what you will do here, you have to simply put the values of m one by one, like m equal to 1, m equal to 2, m equal to minus 1 and m equal to minus 2, and you have to check at which value of m this polynomial becomes a cubic polynomial. What is cubic polynomial? When the power of x is 3. Second question, state the degree and the type of the given polynomial. As I just discussed, degree means highest power of the variable. So here it's 4, and then the type of the polynomial is biquadratic in terms of degree. Let's move to next topic. Second topic is zeros of a polynomial using graph. Under this topic, again I've written two questions for you. In first question, a graph is given to you and you have to find the number of zeros. How we can do that? You have to simply see that this graph intersects x-axis at how many points? It's 1, 2 and 3. So answer is 3. Let's move to second question. If graph of px passes through the points minus 6 comma 0, 0 comma minus 30, 4 comma minus 20 and 6 comma 0, then you have to find the zeros of the polynomial. As I just discussed, what is zeros of the polynomial? When it intersects x-axis, and when it intersects x-axis at those points, what is 0? Y is 0. So you have to see out of these 4 points in which points y is 0. So here y is 0 in minus 6 comma 0 and 6 comma 0. So here the answer is minus 6 and 6. So here we have two zeros. Let's move to third topic. Third topic is zeros of a polynomial. Under this topic, I have written four questions for you. First question, the zeros of the polynomial. Polynomial is given to you x square plus 25x plus 156. You have to tell the nature of zeros. Both are positive, both are negative, or one positive, one negative, or you can't determine by seeing the polynomial. How you will do that? You know that how we can find the sum of zeros, that is minus b by a, that is minus 25 by 1. I can simply write minus 25. How we can find product of zeros? That is c by a, that is 156 by 1. Now you know product is positive. When product is positive, when both the zeros are either positive or both the zeros are negative, that means answer is somewhere between a and b. Now how we'll decide that? We'll decide by seeing the sign of sum. If sign of sum is negative, that means both the roots are negative. Let's move to the second question. Find the other zero of the polynomial, and polynomial is given to you, that is x square minus 4x plus 1, and even they gave you 1 0. How you can find the other zero? Just see carefully here. When the coefficients of polynomial are rational, here coefficients are 1, minus 4 and 1, all are rational. And when the coefficients are rational, then irrational zeros always occur in conjugate pairs. That means if one zero is 2 plus root 3, then other one will be 2 minus root 3. What you have to do here, you have to simply change the sign of root. It's root 3, so you will change it to minus root 3. Let's move to third question. If the zeros of a quadratic polynomial ax square plus bx plus c, where c is not zeros, are equal. Here they gave you that zeros are equal. So just take one example. I can say x plus 3 whole square. Here both the zeros are minus 3, or I can take x minus 3 whole square. Here both the zeros are positive 3. If you will expand this, what you will get? In first case, you will get x square plus 6x plus 9, and in second case you will get x square minus 6x plus 9. Did you observe something here? Yes, the coefficients of x square and the constant term sign is always same. That means the option C is correct. Let's move to fourth question. Find the zeros of the polynomial. They can give you polynomial, and this is a very important question according to NCRT. It can come for 2 to 3 marker. Now you have to verify the relationship also between the coefficient and zeros. What you will do, whenever you the coefficient of any you can say x square or x, its fraction, you have to take LCM. So you will multiply this whole polynomial by 6. So your polynomial becomes 6x square plus x minus 12. Now you have to solve this. You can find the zeros using middle term split or quadratic formula, and then you will get the values of alpha and beta. Then you have to verify the relationship, that is alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. Let's move to fourth topic, forming polynomials. Under this topic, I have written four questions for you. First, form a quadratic polynomial whose zeros are minus 2 and 5. How you can form a quadratic polynomial when zeros are given to you? You can simply write k into x square minus sum of zeros into x plus product of zeros. So here, sum of zeros is minus 2 plus 5, that is 3x, plus product of zeros minus 2 into 5, that is minus 10. So at last you can simply write here minus, that is k into x square minus 3x minus 10. Let's move to question 2. Form a quadratic polynomial whose sum of zeros and product of zeros is given to you. So in this question, you can directly put the values k into x square minus sum of zeros, that is minus root 2x, plus product of zeros, and plus minus is minus, so minus 3 by 2. And you can also multiply this whole by 2. That is, you can also write k into 2x square minus 2 root 2x minus 3. Let's move to third question. If alpha and beta are the zeros of this given polynomial, that is kx square minus 5x plus 1, then you have to form a quadratic polynomial whose zeros are alpha square and beta square. Now how you will do this? First you can find the value of alpha and beta, because it is given that alpha and beta are the zeros of this. To find the zeros of this, you can use either middle term split or quadratic formula, whatever you want to use. Then once you know the values of alpha and beta, you will simply take their square. Like my alpha is 2 and beta is 3 example, so you can say 4 and 9. So once you know the value of alpha square and beta square, you can put values of alpha square and beta square in this formula, like k into x square minus sum of alpha square plus beta square into x plus alpha square into beta square. Let's move to fourth question. If alpha and beta are the zeros of a quadratic polynomial such that alpha plus beta is 24 and alpha minus beta is 8, you have to find the quadratic polynomial. So how we'll do that? As you know that whenever we have a pair of linear equation in two variables, we can simply find the values of alpha and beta. So what you will do, you will use elimination and find the value of alpha and beta. And once you know the values of alpha and beta, you can simply put those values in this formula, like k into x square minus alpha plus beta into x plus alpha into beta. So let's move to topic 5, finding value of k. Under this topic, I have written 6 questions for you. First, if one zero of the polynomial is reciprocal of the other, just see this word carefully. Whenever the word is reciprocal, whenever the zeros are reciprocal, you know that one zero is alpha, so other one is 1 by alpha. So you know that in this case, your product is always 1. So you have to simply put that c by a is 1. So what is your c here? This minus k plus 2, and your a is 6. So simply divide this and write it's equal to 1 to find the value of k. Let's move to second question. If the zeros of the polynomial are additive inverse, so whenever the word is additive inverse, so you know additive inverse means that if one zero is alpha, then other one is minus alpha. So in this, you know that your sum is always 0, so just put minus b by a as 0 to get the value of k. Let's move to Third question. If alpha and beta are zeros of x square minus 6x plus k and 3 alpha plus 2 beta is 20 and you have to find k. In this type of question, because in a polynomial you have two variables, so you can't find the value of alpha and beta directly. So what you will do here, you will just break this in terms of sum or product. So in this case, we can break this in terms of sum. How you can break this? You can write twice of alpha plus beta plus alpha is equal to 20. And you know what is your sum here? What is alpha plus beta? That is minus b by a. And minus b by a means 6. So 2 into 6, that is 12 plus alpha is 20. So your alpha is 8. And now once you know the value of alpha, so you can just put it here to find your beta. Now you know your alpha and beta. How you will find k? Just see the position of k. K is constant. That means you can find k by putting like product is c by a. And what is product of zeros? Once you know alpha and beta, you can simply put alpha into beta is equal to c by a, and c by a is k by 1. So product of zeros is equal to k. Let's move to fourth question. In fourth question, again alpha and beta are zeros of a polynomial, and again here we have two variables. As I mentioned, whenever we have two variables, we can't find the value of alpha and beta directly. We have to always reduce our expression to find sum and product. So here you know the formula for alpha square plus beta square. What is alpha square plus beta square? That is alpha plus beta whole square minus 2 alpha beta. And we are left with plus alpha beta. That this is given 19 by 9. So you will solve this and you will get value of k. Let's move to fifth question. Here the sum of zeros is given to you that it is 1. So simply put sum is equal to 1, and what is sum? Minus b by a is equal to 1, and you will get your value of k. Let's move to sixth question. In sixth question, again in this given polynomial we have two variables. So again you have to use the formula of alpha minus beta whole square. And what is that? Alpha plus beta whole square minus 4 alpha beta. And you know how we can find alpha plus beta? That is minus b by a. How we can find the value of alpha into beta? That is c by a. Just put your values here and you will get your answer k. Let's move to next topic. Sixth, number of quadratic polynomials. Under this topic, I have written two questions for you. First, how many quadratic polynomials can be formed having zeros, minus 5 and minus 3? It might be possible that you are thinking, what is the formula for quadratic polynomial? That is x square minus sum of zeros. That is minus 8, because but minus minus is plus, plus 8x, then product of zeros. That is again positive 15. Did you observe something here? This is not the only one quadratic polynomial, because in formula we have k outside. And what is k here? It's any real number. So answer is always more than 3. Let's move to second question. Assertion. The number of polynomials of degree 3 is infinite. Is it correct? Let's write one polynomial, x cube. It's degree 3. I can also write 9x cube. You can also write 4x cube. So we can write any coefficient before x cube. So yes, it's correct that number of polynomials of degree 3 is infinite. Reason is coefficient of a polynomial can be any real number. Yes, it's correct, and it's the correct explanation. So answer is A. Let's move to last topic, that is value of expressions involving alpha and beta. So under this topic I've written two questions for you. First question, if alpha and beta are zeros of this polynomial, the what is polynomial here? X square minus 6x plus 5. As you observed here, that here there is only one variable, that is x. So here you can directly find the value of alpha and beta either by middle term split or by quadratic formula. Once you know the value of alpha and beta, you can simply put it here to get your answer. Let's move to second question. If alpha and beta are the zeros of polynomial 3y square minus 6y plus 4, you have to find the value of this expression. As you know, again here we have only one variable, so we can simply find the value of alpha and beta again by using middle term split or by quadratic formula. And once you know the value of alpha and beta, you can directly put it here. Or if you want to find the sum of zeros, like alpha and b plus beta is minus b by a and alpha into beta is c by a, and then you can find the LCM of this, and you can convert your expression in terms of alpha plus beta and alpha into beta, and you can directly put the values here. So in this case, you no need to find the value of alpha and beta. So practicing questions from these topics will help you score better marks in your board exam. Stay focused and keep practicing. Thank you everyone.